Okay, yeah, so, right, as Romina said, the title is The Scope and Significance of the Adoption Problem. And this did originate as a paper for Paul Boghossian's and Crispin Wright's seminar on the epistemology of logic last semester. Actually, what I'm going to do today has changed quite a bit since I wrote that paper. That paper was a bit more skeptical about the significance than what I'm going to present today. Basically, just because as I've kept thinking about it, my thoughts on this has changed. This is still very much, my thoughts on this are still very much in development. Just by one other bit of disclaimer, I started preparing for this by kind of putting everything I thought would be a reasonable, amount of things to go into a talk into some slides, and then soon discovered that that was much more stuff than was actually reasonable for a talk. So that's just to say, like, as I go through, I'm going to end up skipping some slides. I decided to keep them that way. If people during the Q&A ask things that are related to them, I'll still be able to refer to them. Okay, so let me get right to it. Okay, so the adoption problem, as I'm going to use this term, refers to a certain argument or argument form that was introduced by Saul, famously in a seminar in Princeton in 1974, and was significantly developed in Romina's dissertation from 2015, What the Tortoise Said to Kripke. And very roughly, the idea is that for at least some rules of logic, you can't adopt them because you would already need to have those rules of logic in order to go about the process of adoption. So that's just to get us started, a very rough idea. We'll narrow in on a more precise notion as we go forward. So just to get a little bit more of a sense, I want to briefly mention this Harry case from Romina's dissertation. So Harry is stipulated to be someone who has some concept of all, but has never instantiated and doesn't know how to instantiate. So we want to help Harry out. We tell Harry, hey, Harry, can't keep going around like this, not knowing how to instantiate. Just take our word for it. All universal statements imply all of their instances. Harry says, okay, you study this logic stuff. I guess I'll accept that. And Harry does genuinely accept that claim. So then we give Harry some other specific universal statement. The example in Romina's dissertation was all the animals in the movie Madagascar talk. And Harry accepts this as well. And then we ask Harry, does Alex the lion, who is an animal in the movie Madagascar, does he talk? And Harry says, well, I'm not sure. I think I need more information. Maybe I should go watch the movie. And when you look into what's going on, it just seems that though Harry has actually accepted the statement, all universal statements imply all their instances, he's unable to use that statement and apply it to the specific universal statement, all the animals in the movie Madagascar talk, because to do so, we need to recognize that specific universal statement as an instance of the universal claim, all universal statements imply their instances. But by stipulation, that's what he couldn't do. And so because he would need to instantiate on the sentence that he accepted in order for that sentence to actually help him instantiate, that sentence does not help him instantiate. And so despite accepting a statement of universal instantiation, he fails to infer according to it. And so thereby fails to adopt it. And so the idea is supposed to just be that anyone trying to rationally adopt at least certain rules of logic is going to be in Harry's situation. They can accept whatever statements of logical rules they want, but at least for some of those rules, unless they already have those rules, adoption is going to fail. So that's just to get, again, just a rough sense of what the adoption argument is on the table. Let me now briefly just say something I'm not going to talk about in this talk, and actually say a little bit about why I don't want to talk about it. Notice that the argument, as I've just briefly glossed it, kicks in after Harry accepts the statement of universal instantiation. it doesn't seem to be dependent on what Harry's motivation was. It doesn't seem like the fact that Harry took this statement on pure testimony makes any difference. And so we should not expect the argument to really be sensitive to what our motivation or justification is for wanting to adopt a certain rule of logic. For that reason, it seems to me that the question of whether we want to revise logic on empirical or a priori grounds is a bit of a red herring when it comes to the adoption argument. It seems to me that the heart of the adoption argument targets the possibility of revision of logic, or at least certain kinds of revision of logic, regardless of what the grounds for it are. For that reason, I'm not going to talk about anti-exceptionalism or Quine or Putnam, some of these, which are things that sort of do get discussed a lot in this topic, and I think had a lot to do maybe with the initial motivation for coming up with the adoption problem. It seems to me like the heart of the problem isn't really about what the justification is for revision. So let me say then what I do want to do. I want to first introduce a somewhat more precise way of understanding what the adoption problem, like how it works. I want to sort of give an account of what makes the argument actually work. And I want to use that account to introduce a distinction between what I'm going to call unadoptability and indispensability. And that distinction is then going to matter a lot for everything that comes after. Then I'm going to take a brief detour to defend the relevance of the argument to logical debates. I want to argue that whether the adoption argument works or doesn't does end up mattering for debates about what logic is correct. Then I want to talk about start the work of trying to show which rules of logic are indispensable and which are unadoptable. Now, partly because of what I said earlier that I put too much in here than I actually have time for. Mostly I'm going to be talking about what's indispensable, not about what's unadoptable. But as you'll see, I'm going to try to also show that in the indispensable, what rules are indispensable is the more philosophically important and interesting question. And as I go along, I'm going to try to convince you that the adoption argument can be repurposed as an argument against classical logic. Okay, so on to my account of how the argument works. Recall the case of Harry that I started with. It seemed like the Harry case worked on this kind of model. Harry tries to adopt the rule of universal instantiation, and the way he tries to do it is he accepts a statement that carries its content, and then the idea is he's supposed to be able to go from a certain premise or set of premises to a conclusion licensed by that rule in a way that the statement of the rule that he has accepted is supposed to help him make that inferential journey, where the statement of the rule plays some kind of crucial role. So let's suppose that that's right. This to me suggests a way of understanding how the adoption argument really works. And the first step for that is to propose a certain schema for what the contents of rules are. So I'm proposing this as a general schema for the content of any inference rule, whatever. This is a schema because it's schematic on these little alphas. So you can put in any condition for alpha 1 through alpha m plus 1. And also, I guess, schematic for the n. You could have any x1 through xn for any n here. And the idea is that the content of any inference rule is basically a universal claim, where then the thing in the scope of a universal claim is a conditional. And in cases where the antecedent of the conditional is conjunctive, or in some cases, let's say the antecedent of the conditional is conjunctive. Now, I'm saying here that n and m are greater than or equal to 0. So I guess I'm putting this here just for maximum amount of generality. But I mean, if in the case where n equals 0, this is actually not a universal claim. So that's a sort of pretty weird limit case of a rule where it's not actually a general rule at all. Again, that's just for maximum generality. we don't have to take the n equals 0 case very seriously. And same thing, if m equals 0, then the thing in the scope of the quantifier won't be a conditional at all. Again, that would be a weird case. I guess that's a case of a law, of what we usually call a law as opposed to a rule. And then the case of m equals 1 is where you have the antecedent is not conjunctive. And you can, again, just think of these as kinds of limit cases. Now, technically speaking, any statement can fit this schema. But the idea for why we should take this schema as reflecting something about rules is that the idea is that this is the schematic content of rules in the sense that for any rule, any instance of that rule, the premises are going to correspond to instances of the conjuncts in the antecedent of this statement of the schematic contents of rules. And then the corresponding conclusion is supposed to correspond to the consequent of this statement of the schematic contents of rules. Okay, now, supposing that this is right, that this is a good way of understanding what the contents of rules is. I have here, I guess, some examples just to try to, of familiar rules that kind of fit the schema. So, okay, disjunction introduction, I'm saying for all, the content is for all P and all Q. If P obtains, then P or Q obtains. I'm putting obtains in brackets because I'm kind of postponing the question of whether quantification should be understood as first order quantification or if it can be higher order quantification. So if you have propositional quantification, you don't need that obtains there. But if you have first order, then you do. So that the disjunction introduction case, for example, is a case where the antecedent isn't conjunctive. So you have some other examples here that all fit the schema. The case of LEM is a sort of limit case where the thing in the scope of the quantifier isn't a conditional. So this is a law as opposed to a rule in the usual understanding. But again, we can just think of it as a limit case. And then top introduction, it would be the limit case where it isn't even a general rule. So supposing that this account of the schematic contents of rules is right, that allows me to give this thing I'm calling a schematic argument, the schematic argument. And the schematic argument is as follows. Suppose I accept this claim that I'm calling S rule. Now S rule, you will notice, looks exactly like what I just called the schematic contents of rules. But I'm just stipulating that rather than S rule being now to be understood schematically, assume that there's some specific phi 1 through phi m plus 1 and a specific n that we're dealing with. So take this to be a specific sentence. I'm just kind of not telling you what it is because I don't want to assume anything about it other than that it satisfies the schema. So suppose I accept that statement of that S rule. And suppose I also accept the sentences in this set I've called S premises, which are in effect just the sentences that correspond to certain instances of the conjuncts of the antecedent in S rule. And now suppose that I want this statement S rule to inferentially guide me from the set S premises to the corresponding conclusion. Well, the first thing that would need to happen is that I would need to apply universal instantiation to the statement S rule n times. And that will allow me to fill in for the quantifiers, sorry, for the variables in these little phi terms in the conditional. I fill in the terms that are in my set as premises as appropriate, and that gives me the unquantified claim as conditional. Okay, which is the conditional that occurred in S rule, but now with the appropriate terms filled in. Now it seems like in order to go from this to the appropriate conclusion, I'm going to need this antecedent so I can detach. In order to get the antecedent, I need to move from the set of S premises to that sentence that is the antecedent. In order to do that, I'm going to need to use conjunction introduction because I have all the sentences in the set S premises separately. So I need to use conjunction introduction m times in order to get this one sentence, the antecedent. And then I can use modus ponens to go from the S antecedent and the S conditional to the appropriate S conclusion. Now, what is the point of this argument? The point of this argument is to show that assuming that the schematic content of rules is right. In other words, that all contents can be thought of as having, all rules can be thought of as having content that satisfies that thing I call the schematic content of rules. Since I assumed nothing about S rule other than that it satisfied that schema, then what this argument prima facie shows is that any statement that carries the content of a rule can only guide us to infer from some set of premises to the corresponding conclusion, so long as we can antecedently use these three specific rules that I used in the argument that I just went through, namely universal instantiation, conjunction introduction, and modus ponens. There have to be exceptions stipulated for the limit cases where we don't have a quantificational rule, or one that isn't a conditional, or one that doesn't have a conjunctive antecedent. But putting that aside, you need all those three rules. And it seemed we didn't need any others. Okay, so you might ask, okay, why does this matter? Why does it matter what rules we need to, in general, go from the statement of a rule and some premises to the corresponding conclusion? So that brings up the question of what adoption really is. So I'm proposing here a way of understanding what at least some necessary criteria for what adoption is as it works in this argument. So I'm proposing that for a subject S to adopt a rule R at time t, it needs to be the case that prior to t, S is unable to infer according to R. So it better be the case that you don't already have the rule if you're going to adopt it. S begins to infer according to R at t. In other words, if you're going to adopt it, you better start being able to infer according to it. And crucially and most controversially, it needs to be the case that S satisfies the second condition. In other words, S begins to infer according to R under inferential guidance from a statement of R. Or I mean, maybe to put it slightly weaker, from something that carries the content of R. Now, I'm going to say more about condition 3 later, but for now, in case you're wondering what motivates condition 3, the way I think of it is that what motivates condition 3 is the rational in rational adoption. The idea is, if you're going to rationally adopt, and again, it doesn't matter what your grounds are, so I'm not taking that back, but so long as you're adopting as a result of having gone through some kind of rational process, then when you start inferring according to that rule, you're doing so should be in some sense guided by or sensitive to the output of that rational process. So you went through a rational process. Out of that rational process came something like, okay, I guess I better start being guided by the rule R. And then you have the content of R there. And it seems like you're now actually having the behavior of inferring according to R should, at least at first, be guided by the thing that was outputted by your rational process in order for your adoption to be rational adoption. At least that's what I want to say for now to motivate this condition 3. So supposing that the schematic argument works and that we have these 3 criteria for adoption, here's how I see the adoption argument as working. Here's an argument for the unadoptability of modus ponens. Suppose Irene now adopts modus ponens. Then she was until now unable to use modus ponens. That's from criterion 1. She now begins to infer according to modus ponens. That's criterion 2. And she does so under inferential guidance from a statement of modus ponens. That's condition 3. But if one is antecedently unable to use any of those 3 key rules, universal instantiation, conjunction introduction, and modus ponens, then a statement of any rule whatsoever cannot inferentially guide one to infer according to that rule. And that was the conclusion of the schematic argument. The conclusion of the schematic argument was these 3 rules are special. And unless you have all 3 of them, you won't be able to be guided by the statement of any rule to infer according to it. And so since Irene is antecedently unable to use modus ponens, a statement of modus ponens cannot, and so does not now inferentially guide Irene to infer according to modus ponens. So we've got a contradiction. The supposition that Irene adopted modus ponens is false. So modus ponens is unadoptable. That's kind of my account of how I see the adoption argument working. Now, again, supposing that this is right, something that I want to emphasize is that the argument seems to show that these three rules are kind of special in that we need them for the adoption of any rules, given that you have the appropriate exceptions for the limit cases. The fact that the rules themselves are unadoptable seems like just a special case of the fact that rules are in general unadoptable when you don't have those three. And that's what motivates the distinction that I mentioned earlier, and that is important for everything that comes after. And it's this distinction between being unadoptable and being indispensable. So I want to say that a rule R is unadoptable if and only if inferring according to R under inferential guidance by a statement of R requires use of an extension of R. Whereas a rule R is indispensable if and only if, for an important class of rules, inferring according to any rule pi in that class under guidance by a statement of pi requires use of an extension of R. So just intuitively, the idea is a rule is unadoptable if you need that very rule to be guided by a statement of that rule. And a rule is indispensable if there's some fairly general class of rules such that you need this rule in order to be guided by a statement of any rule in that class. So I want to say so far, we seem to have prima facie reason to think that all three of the rules that I've highlighted so far are both unadoptable and indispensable. I will eventually want to argue that conjunction introduction is neither, and that universal instantiation and modus ponens are indispensable, but not unadoptable. Okay. Yeah, so this thing at the top is just supposed to give you, so if you take these three to be indispensable, the obvious thought of what the important class of rules would be that you need them is that basically it's just the set of rules that aren't the limit cases. So for example, you need universal instantiation to adopt any rule that is whose content is actually a universal claim. And analogously for the other rules. Notice that indispensability does not imply unadoptability. So if a rule R is indispensable, but it is itself not in the important class that for which you need it to be guided by any rule in that class, then it may well be that that rule is itself not unadoptable. But conversely, if a rule is unadoptable, then there's some property of the logical form of the statement of that rule that makes it so that you need that very rule in order to be guided by a statement of it. And then you can take whatever that formal property is of the statement of it, you can take the class of rules whose statements have that formal property as being the relevant important class. And so, look, important class is going to be vague, obviously, but I think on a reasonably lax conception of what an important class of rules is, unadoptability does imply indispensability. Now, I think based on what has been said so far, we should think it not likely that all rules of logic will end up being unadoptable or indispensable. Very quickly, I don't want to go through the details of it, but you can see that if I start with some premise A and I want to get to A or B, so basically I want to use an instance of disjunction introduction. Supposing I don't have that rule, but I accept the statement of it, a kind of natural statement of it, say for all PQ, if P, then P or Q. I can get from the A to the A or B using just universal instantiation and modus ponens. No use of disjunction introduction itself will be needed. And so we shouldn't think that disjunction introduction will be unadoptable. You might think at first that disjunction introduction might be indispensable because you might think, won't you need it for rules with disjunctive antecedents? But the reason you don't have to worry about rules with disjunctive antecedents is that for a rule with disjunctive antecedents, you can always just think of it as a number of distinct rules, one for each disjunct in the antecedent. And if you accept all those rules, then you will have every instance of the rule with the disjunctive antecedent. And that's why you don't need disjunction introduction in order to be, you don't seem to need disjunction introduction to adopt any general class of rules. Okay, a kind of last general point I want to make about the argument. Sometimes it's said that the adoption argument applies to basic rules of inference. So I guess it depends what basic means, but I guess the point I want to make is that if basic is supposed to mean something like underived, we shouldn't think that this is so. So the adoption argument, as I'm reading it, really targets certain rules specifically. So far, it seems like these three. And so we should think that, if any of those rules is derived, the adoption argument still targets them. And so maybe implicitly we'll target whatever rules you need to derive them. But if there are any basic rules that are not required to derive these special three, then any such basic rule will be immune to the adoption argument. So if you have a system where disjunction introduction is one of your basic rules, just because it's basic, you shouldn't expect that the adoption argument will apply to it. And the idea is these three have fallen specifically out of the schematic contents of rules. So really, this claim is all kind of hinges on that. Okay. Now here's where I'm going to start skipping some things. There were certain challenges to the relevance of the adoption argument to debates and logic that I'm interested in. But like I said, I just put too much in here. And so I'm just going to skip some stuff, including the first thing. So I'm going to skip that first challenge, move right on to the second one. And this challenge is, it seems like the way I put the adoption argument, it intuitively is about adding rules. Like what you do when you go through the process of adoption is you assume I don't have this rule, but I want to get it. And so I'm going to accept the statement of a rule of it. But most debates in logic seem to be about whether certain rules should be dropped as opposed to added. So why does this adoption argument, why is it relevant to those debates? Okay, I have a few different kinds of responses, which I put into these slides because I thought they all brought out something interesting. But I'm going to skip to the one that I think gets to the heart of what I want to say, which is that, and this has already been kind of implicit in what I've said, without the rules that the adoption argument shows to be indispensable, we can't adopt new inference rules in general, not just logical ones, right? Any rule that meets whose content satisfies the schematic content of rules, which I'm saying is any inference rule. You won't be able to adopt new rules at all unless you have the rules that the adoption argument shows to be indispensable. And so the general claim is, the reason that this matters is we do in fact have the ability to adopt new rules. And not only that, we require that ability in order to, well, just kind of reason. And for that reason, any theory of the logic that we in fact use that doesn't feature one of the indispensable rules has to be wrong, because we do have that ability. And any proposal that we drop any of these rules has to be rejected as cognitively crippling. And there, I think that's the heart of why the adoption argument does matter for debates about logic. Okay. Yeah, I had some other stuff here about whether we ever do actually adopt. I'm going to skip it and say I think we do in fact adopt. Okay, yeah, I can come back to that if people are interested in it. Especially since Crispin is here, I am going to stop to talk about this challenge. So a different sort of challenge, not exactly to the relevance of the argument to logical debates, but just more to the notion of adoption in question being a reasonable one. So the challenge is this: presumably inferring involves the following of an inference rule, but the criterion 3 on adoption requires that in order to follow an inference rule, we have to make an inference from a statement of it. Now, what happens there is that if you accept both of these things, anytime that you want to either infer or follow an inference rule, you're going to get stuck in an infinite loop. You're going to have to, and if you want to infer, to do so, you're going to have to follow a rule, an inference rule. To do that, you're going to have to infer from a certain statement. To do that inference, you're going to have to follow a rule, and you'll be stuck doing that forever. And for that reason, criterion 3 has to be rejected. I mean, I've heard other ways of challenging criterion 3, but I think this kind of does get at the heart of what's supposed to be a problem with it. And here's my response, because I do want to defend criterion 3. And I want to say that criterion 3 requires only that when we adopt a rule, we have to infer from a statement of it. It says nothing about what we do when we follow an unadopted rule, nor about rules that we've successfully adopted sufficiently long ago. So the kind of picture I'm proposing is that adoption is a kind of process. And when you're in that process, you have to satisfy condition 3. In other words, your following of the rule that you're trying to adopt has to be guided, inferentially guided by a statement of that rule in the way described by criterion 3. But once you're done with the process of adoption, that no longer has to be the case. And similarly, it doesn't have to be the case for a rule you've never adopted that you just have because you grew up in a society where that rule, you just kind of picked it up that way. And this opens up a way out of the regress, because for any rule that we're not in the process of adopting, condition 3 doesn't apply. So specifically, here's an example to see how this idea is supposed to work. Suppose I want to adopt disjunction introduction. In order to do so, I have to, while I'm in the process of adopting it, move from any given A to A or B in a way that involves inferential guidance from a statement of disjunction introduction. Now that statement is, for all PQ, if P, then P or Q. Okay, now to get inferential guidance from this statement, what do I need to do first? I need to instantiate. Okay, that means I have to follow universal instantiation. But wait, in order to follow universal instantiation, I am going to now have to make an inference from a statement of universal instantiation. That last claim is false, because I am not now in the process of adopting universal instantiation. I'm in the process of adopting disjunction introduction. And so since this condition 3 doesn't apply for a rule that I'm not in the process of adopting, the regress is stopped right there. And I think that what I think is intuitive about this suggestion that criterion 3 applies while you're adopting a rule, but not otherwise, is that because adoption is supposed to be something, it's supposed to be a rational, a process guided by having gone through a certain rational process. The idea is, I went through this rational process. I decided as a result of that process, I'm going to be guided by this rule. But I wasn't already sort of trained in following this rule. So I have to be kind of sensitive to the output of that rational process. Now, once I've, so to speak, internalized the rule, well, then that condition gets laxed, and it's no longer the case that every time I follow the rule, I have to be guided by a statement of it. No, it's only during this sort of like sweet period that where it's sort of for this whole process to be rational that I still have to be sensitive to the output of whatever deliberation I went through. Okay. The last challenge that I want to address that I think is important, and it has to do with equivalent paraphrases. So in the schematic contents of rules, I mean, this argument is really all coming out of the schematic contents of rules, and there's certain connectives that occur in it, but those connectives can always be replaced with, you can always eliminate those connectives by having certain equivalent paraphrases. So for example, the conditional, if you have an if P then Q in there, you can always paraphrase it as not P or Q. And for that reason, you can always write the content of a rule. You can always paraphrase the content of a rule in such a way that you don't need a conditional in it. And so for that reason, you're never going to need to use modus ponens. And so the argument that modus ponens is indispensable has to actually fail. And similarly for all the other connectives, that's the challenge. And I want to say that I think this objection is in one sense sound. I think that's right. You can, of course, always paraphrase these rules. But that just means that the targets of the adoption argument have to actually be understood disjunctively. What I mean by that is, okay, so let's say that I have the content of a rule. It's a universal claim. Okay, we instantiate, and now we've got a conditional. If A then B, and I've already accepted some statement A. I want to go from A, and if A then B to B, I would need to use modus ponens. But you say, aha, no, I'm going to paraphrase. I'm going to instead give you not A or B. Well, okay, now I don't need modus ponens. I need disjunctive syllogism. Okay, well then, what I need now is whatever I need to get to derive disjunctive syllogism. So in this case, negation, elimination, and disjunction elimination. And so what's actually indispensable is not that I have modus ponens, but that I have either modus ponens or whatever I need for disjunctive syllogism, or whatever I might need to make the appropriate move on any other paraphrase that you want. So when I go on to say something like the adoption argument suggests a kind of OR logic that falls out of what the indispensable rules are, strictly speaking, we should think of that as a kind of space of OR logics that's determined by what the indispensable rules are under the various equivalent paraphrases. But I'm not going to keep saying that. I'm going to keep talking about modus ponens because that's the kind of natural way of giving statements of rules. Though, of course, yes, you can paraphrase. Okay, that's the stuff. That's mainly the stuff I want to say about the adoption argument kind of generally. I now want to get into some specifics of some of the specific rules and discuss the indispensability of some specific rules. So the first thing I want to do is very briefly dispense with conjunction introduction. I actually don't think it's indispensable. And it has to do with this thing I just mentioned about equivalent paraphrases. So any conditional with a conjunctive antecedent can always be paraphrased as a series of nested conditionals. And importantly, for any of the conjuncts of the original conditional that we were working with, if you have all those conjuncts and you have that big nested conditional, then you can get the consequent just from repeated applications of modus ponens. Now, I did just say that this issue of equivalent paraphrases I wasn't going to keep mentioning because it just introduces kind of disjunctive indispensabilities. But in this case, it matters because what it shows is that we can trade off the indispensability of conjunction introduction for that of modus ponens. But we already have an independent argument for the indispensability of modus ponens. So for that reason, since we need modus ponens anyway, and modus ponens gets to do all the work that conjunction introduction does, we just no longer end up needing conjunction introduction at all. Okay, now onto the case of universal instantiation. So there are going to be many rules where the content of them quantifies over things that intuitively are not first order. So propositions, or I don't know, or properties or something like that. And so we have to kind of decide how we are understanding that kind of quantification. So propositional inference rules, like we've been talking about, disjunction introduction, says things like, for all PQ, how do we understand that quantification? We can understand it as actually not quantification at all, but we can understand that the contents of these rules are actually just schematic. There's no genuine quantification in the content of the rules. We can understand it as involving first order quantification over syntax, or we can understand it as involving sui generis higher order quantification. So I want to consider some of these options in turn. First, the schematic option, I want to briefly say, I don't think is actually a distinct option. So when you say, look, the content of the rule disjunction introduction is just the schema, if A, then A or B, what I want to say is, since we can't accept every instance of that, to just say that that's a schema doesn't tell me how I'm actually to understand its content. If I think about how I actually understand its content, it's got to be something like every formula of the form, if A, then A or B is true. But if that's the case, this schematic option is really just disguised first order quantification over forms of formulas. And so this is not really a distinct option in my view. So let me go on to the first order option. Now, the idea with the first order option, so I'm going to focus on quantification over sentences as opposed to properties or open formulas. But basically the idea is you have, you basically just use Gödel numbering to give names to sentences. And then you add certain functions to your language so that you get to have certain nice compositional features of the names of sentences. So for example, you add this function neg, which if you take as input the name of a sentence, will output the name of the negation of that same sentence, and so on for certain other functions you need to add in order to be able to talk about any kind of sentence in your language. The details of how that works exactly don't matter that much, so I'm not going to sort of belabor the details of it, but that's the general idea. And of course, you also need to add now a truth predicate, right? Because the idea now is we're quantifying over just first order entities, just that these entities are sentences, they're names of sentences. And so we need to be able to predicate something of them. And so specifically, if you want to now in this kind of format, give the content of this disjunction introduction, the way you would do it is by saying something like for all X and all Y, if X is true, then the disjunction of X and Y is true. And so that's why you need the truth predicate to even make this grammatical. Now, I mean, as I see it, for this to have the meaning that we want it to have, it already should be the case that X is true if and only if the sentence named, sorry, that X is true if and only if the sentence named by X is true. Like that should already be true. In other words, the Tarski schema should be true for this to have the intended meaning. But of course, that's obviously very controversial. So I'm going to set that aside and instead try to look at this from the light of the adoption argument. What do I need to move from a given A to a given A or B? Right. So the idea is I've got some A and I want to use the content of this disjunction introduction. We're supposing I'm going to accept the content of a sentence that carries the content of this disjunction introduction, and I want to be able to use it to move from A to A or B. What do I need to do that? Well, we should see the pattern by now. The first thing I'm going to need to do is instantiate. And if I instantiate, what I'm going to get is the conditional. If I instantiate appropriately, what I'm going to get is the conditional. If A is true, then A or B is true. Now I started with A and I need to get all the way to A or B. So first thing I want is to somehow get this antecedent so I can detach. So I'm going to need to go first from A to A is true. Once I've got that, I can use modus ponens to detach and I get A or B is true. But now I need to go from that to A or B and I've concluded my inference. And so what did this process, which it seems like this is the process I need to be able to do to adopt this particular rule, what did it require of me? Well, unsurprisingly, it required universal instantiation and modus ponens, but it also required both of the truth rules, the introduction and elimination rules for the truth predicate. By the way, I'm going to use these little double arrow formulations are just ways for me to refer to certain rules in a way that's supposed to be neutral as to how you give their content. This is just schematic formulations of rules, yeah, where I'm not yeah, I'm not trying to say anything about what their content looks like. But anyway, yeah. So you need to use these two rules, and there was nothing so special about this junction introduction that made it so that I needed both. Any propositional inference rule that isn't, well, okay, let's see, at least one that isn't a law. In other words, one that is will have an actual antecedent, will require me to use both of these rules in just the same way that I use them now, which yields this conclusion, which is that if you're doing this first order approach to how you understand quantification in the contents of rules, then the truth rules are going to turn out to be indispensable. They're indispensable, and the quote important class of rules that they're indispensable for is just the class of rules of propositional inference rules. So it seems to me that Saul very strongly hints at this in a footnote to this paper that is coming out called The Question of Logic, which I think is a transcript of a talk that he gave at Pittsburgh in '74. But he says, note that one would have to universally instantiate the statements of logical connections to get any consequences from them. And one would have to use the Tarskian disquotation principle and modus ponens. So now, of course, we know that classical logic augmented with the truth rules entails everything. And so it seems to immediately follow that if this approach is right, in other words, if the content of inference rules are to be understood via first order quantification, then classical logic augmented with the ability to adopt new rules in general is trivial. Why? Because we need the indispensable rules to adopt new rules in general. And it has turned out that the truth rules are indispensable. And so as far as adoption considerations are concerned, we can't drop the indispensable rules. We need them for the ability to adopt. And so as far as the adoption related considerations are concerned, something in classical logic has to go. It can't be universal instantiation or modus ponens, because those are also indispensable, or seem to be, but something else. Okay, now maybe you really don't like this conclusion. You like classical logic, and so you're thinking maybe this first order option wasn't such a great idea. Maybe we should have gone with that higher order option. Well, unfortunately, like I said, I just put too many things on these slides, and I have to make some choices about what to actually go in. So even though I have some things here about the higher order option, I'm going to completely skip it. So yeah, the basic upshot, I don't like it, but yeah, I don't actually have the time to go over why I don't think it actually works, but I can talk about it during the Q&A if you're interested. So the last main thing I want to talk about is something actually that I'm still very unsure about what to think about. I'm much less confident on this section. And it's this. It seems like rules are not mere generalizations. They're supposed to guide us, and that suggests that their content carries normative force. And that suggests that the gloss that I gave, what I proposed as the schematic constants of rules is sort of missing something important. So when I say the content of disjunction introduction is for all P and Q, if P is true, then pure Q is true, it seems like that's missing something. It's missing the fact that the rule is licensing me to do something. And that it should be understood as something more like for all P and Q, you may infer pure Q from P, where that may is kind of carrying that normative content or that normative force. Now, I think that sounds right, but unfortunately, I'm not happy with any of the ways that I've at least thought of trying to make sense of that. So here's a first thought, right? Like, just put that you may infer in the consequent. So I'm going to use this infer just as an abbreviation for you may infer. And so you might think disjunction introduction can just be for all P and all Q. If P is true, then you may infer pure Q. But this seems to be false. It seems we may not infer A or B whenever A is true. We have to accept A in order to be able to license. In order to be licensed to infer A or B. So you might think, okay, well then use accept, something like for all P and all Q, if you accept P, then you may infer P or Q. But in order to actually use this in an adoption argument kind of thing, in other words, in order to be guided by this statement, you're going to need to go from some A, your premise A that you're trying to move from, to I accept A. That just seems like not a valid inference rule. It's not the case that A implies I accept A. So I don't know, maybe this idea can be rescued, but I got stuck with it at that point. I was anyway, it seemed anyway a bit cleaner to try to get rid of the conditional altogether and to just simply introduce a dyadic version of the you may infer predicate. So rather than just having you may infer be a predicate of one thing, just as you can infer that, rather have it be a dyadic predicate, where the first argument place takes a set of sentences which are supposed to be the premises, and the second argument place takes the thing that's supposed to be the conclusion. And that way you can say, for all P and all Q, you may infer P or Q from P as just an atomic claim. In order to be guided by this in the way that we've, in an adoption kind of situation, you're then just going to need an elimination rule for this you may infer predicate, which basically just says whenever you have the things, whenever you have the set of sentences in the first argument place, and you have the you may infer claim, you then can get the thing in the second argument place, the conclusion thing. So here's some things that should look pretty good about this approach. It seems like maybe it's got some hope of accounting for this normativity of the contents of rules. And it also replaces the indispensability of both modus ponens and the truth rules with the indispensability of just this elimination rule for the you may infer predicate. And that seems to give us some hope of keeping classical logic, because now we're not tied to keeping the truth rules. They're no longer indispensable. Never mind this tempting thought. I'm not going to go into that. Basically, the thing I want to say is that it seems to me that this approach walks into a version of the validity Curry paradox, and one where at least some of the solutions that might seem appealing in the usual validity Curry paradox won't really work here. So here's how I'm thinking about this right now. I'm not entirely happy with this presentation, but this is what I've got so far. First, it was stipulated that this infer predicate I'm using is a mere abbreviation of you may infer. And so the following claim is completely unavoidable and trivial. You may infer that you may infer alpha from gamma from its being the case that you may infer alpha from gamma. That's just identity or reflexivity. That shouldn't seem controversial. Now, under the current approach, whenever you can move from some gamma to a certain A in one inferential step, there's a rule that licenses that. And the content of that rule is going to be a universal claim, where one instance of that universal claim is going to be the actual sentence, you may infer A from gamma. Because that is what this proposal is. This proposal is that we understand the contents of rules as statements of the form, you may infer this from that. And so if you can move in one step, in other words, using only one rule, then an instance of that rule is going to be the actual claim, you may infer A from gamma. And this allows me to establish this thing I'm calling infer I, which is just that you may infer that you may infer alpha from gamma from there being a rule R, such that R licenses the inference from gamma to alpha in one step. Now, if you accept that, and you also accept a transitivity rule for the you may infer predicate, which is given right over here. It's kind of what you would expect intuitively from a transitivity rule. Then from a typical kind of validity Curry sentence, in other words, the sentence that says of itself that you may infer absurdity from it, you can derive an actual absurdity. Now, I'm not going to go over the derivation. But suffice to say, all you need are the 3 infer rules I've mentioned, some structural rules, I guess, and substitution of equivalence. Now, it should seem right away that the transitivity rule is the obvious suspect. In fact, I want to claim every other option is highly unappealing. The main claim in a way that I want to make is that it doesn't make sense to reject the infer I rule because it's just incompatible with this account of the contents of rules and with the stipulated meaning of the infer predicate, right? We've just stipulated that the infer predicate just is an abbreviation of you may infer, and that the contents of rules are claims of the form you may infer. So it seems like we can't really, under this approach, get rid of the infer I rule. We can't get rid of the infer E rule because it's indispensable. That's our detachment rule. So we'll be stuck having to reject either substitution of equivalence or a structural rule if we don't want to get rid of the transitivity rule. And so the thought you should be having is, yeah, let's get rid of this transitivity rule for the infer predicate. It seems independently implausible anyway. It's not the case that you may infer across a chain of licenses to infer when you can't recognize each element of the chain. I think that's what's really importantly different about this from the usual validity query. Since we're talking about what you may infer and not about validity, there's no even prima facie plausibility to the idea that you have transitivity going across the board. But my claim is this is not really going to help us get out of the paradox, because we can just restrict the transitivity rule to instances where both of the infer claims in the premise set of an instance of the transitivity rule are recognized by the reasoner. And you can also additionally, if you want, stipulate that neither of them is neither of the infer claims in the premise set is itself inferred via a use of transitivity. It seems to me that this suffices to put to rest any concerns about cognitive limitations. You have 2 infer claims, you recognize that both of them are true and you accept both of them. It seems like you are there. I don't see any non-ad hoc grounds for rejecting the ability to then go the one step of transitivity on them. But that's all that you need to get the derivation of absurdity at the end. And so here's where I want to end on this particular topic of this infer option. This option traded the indispensability of modus ponens and the truth rules for that of the elimination rule for infer in a way that seemed to give us hope of getting rid of the truth paradox. But it just replaced it with this you may infer paradox. And if what I'm saying is right, that getting rid of the infer rules is not really viable, this is not a beneficial trade because it actually just narrows down the possibilities for how you can deal with the paradox. There are much fewer ways left of dealing with the you may infer paradox than there are for the regular truth paradoxes. So this looks like not a good trade. On the other hand, this option seemed to capture this normative force thing that we started with this section talking about, which the initial approach arguably doesn't. So I'm still not sure what I think about this. I guess for now, I'm just saying that neither option seems compatible with classical logic, broadly understood to include structural rules and substitution of equivalence. Okay, now in the last couple of minutes before I end this, I'm just going to say a couple of quick words about unadoptability. So far I've argued that universal instantiation, modus ponens, and the truth rules are indispensable. And then I have some slides about why they're not unadoptable. And I'm not going to go over the details of it, but the basic strategy is, if you remember, unadoptability was supposed to be where a rule R is unadoptable if being inferentially guided by a statement of R requires R itself. And so the general strategy is, well, if there's a restriction of R such that that restriction suffices for inferential guidance under a statement of the original rule, then that original rule is not unadoptable. And so, yeah, then there's some stuff here about kind of narrowing in on further and further restrictions and to show that each successive one is not unadoptable. Presumably then there's a kind of limit at which you do get a restriction that is unadoptable. But like I said, I don't think that, I'm not going to go into that. I'm going to actually just end on this final slide I have here, which the notions of indispensability and unadoptability seem to generate two senses of what you might mean by a kind of or logic that comes out of the adoption problem. The first sense is the minimal logic required for the ability to adopt rules of any, quote, important class. And this is the logic determined by the indispensable rules, and I've argued includes only universal instantiation, modus ponens, and the truth rules. The second sense is a kind of much more minimal logic, and it's the minimal logic from which we could adopt our way back up to the ability to adopt rules of any important class. And this has just the unadoptable rules, and which will all be restricted versions of the indispensable rule. So the idea is if you have only the or logic in sense two, there's going to be all kinds of rules that you're not able to adopt until you get yourself back up to the or logic in sense one. But luckily, you at least, if you have the or logic in sense two, you have the resources to at least get yourself back up to sense one. And then from there, you'll be able to adopt new rules in general. And for that reason, I think that the sense one is the philosophically most important. And we can think of the main upshot of the adoption argument as being that both the logic that we have and the logic that we should have are extensions of the or logic in sense one, because again, we have and need the ability to adopt rules of any important class. Okay, and that's where I'm going to end it.
All right, well, let's start by thanking our speaker for a cool talk.
Thank you so much. Well, that was great. Yeah. I want to see the whole slide at some point. But
it's hard to keep all this in mind, actually. Yes, very good.
Okay.
I'm going to have to tell them to stop.
What?
I'm going to tell them to stop vacuuming. I'll be back.
Okay. So why don't we go to Hartree first? And if other people have questions, you can raise your hand, your virtual hand, that is, or put a word into the chat.
Great talk, first of all. My only substantial reservation is that, so I'm skeptical that even in your, I'm skeptical that you've actually shown the four rules you mentioned, the two truth rules and the all-in really are indispensable in your sense, because when people want to declare them not valid, they don't usually give them up wholesale. What they do is offer restricted versions of them. And it seems to me that if you don't accept them, but do accept restricted versions of them, you could still run the rules you could still adopt in the sense that you outlined early in the paper. So, I mean, for instance, in the case of all free litigations restrict all elimination, but the kind of restrictions they give wouldn't affect typical uses. In the case of truth, people who restrict one or both of the I and E rules typically say, okay, for the restriction comes in as applied to sentences that themselves contain true or other notions in that ballpark. But I don't think that's required for the applications. And in the case of if then, I think it's similar. I mean, so for instance, if you want to keep the truth rules, then one of the ways around the Curry paradox would be to make some restriction on modus ponens, but again, it's not likely to affect the rules. One thing you might say in this is that, okay, when you're talking about these rules, you really mean the minimal restriction of them required to run the argument. But I think it's not obvious that there's a unique minimal restriction. So there might be different ways of restricting the truth predicate, for instance, and it's not clear that it's not clear that there is going to be one unique or logic singled out here.
Yeah. So I think that largely you're right. And here's how I'm thinking about this, at least for now. Like I said, my thoughts on this are still developing. So I said that, you know, a rule is indispensable if you need it in order to be guided by the statement of any rule in some important class. Now, now take any rule, whatever that important class is. Say that it's just the class of rules whose statements will actually be a conditional within the range of the quantifier. Now, for any one of those rules, in order to be guided by its statement, you don't need full modus ponens. Of course, you can, in fact, the restriction of modus ponens restricted all the way down to just, you know, the schematic form of that rule will do. And so the kind of strong claim, well, modus ponens in general is indispensable, is if you want to be able to adopt a rule of any form whose statement takes any form whatsoever that is still consistent with the schematic content of rules. And so I think maybe the thing to say is like, well, if I want to restrict modus ponens, let's say, as a result of the truth theoretic paradoxes, then maybe there's going to be certain rules whose contents I won't be able to adopt because that would require, you know, one of the instances of modus ponens that I've given up. But maybe it'll turn out that any rule with such a content is the kind of rule that I wouldn't want to adopt anyway. This is the kind of thing, I mean, I'd have to actually think about whether that would actually always be the case. But yeah, that's sort of where my thinking is on this at the moment. Does that make sense?
I think so. I need to think about it also.
Okay, next up we have Crispin, I believe.
Thanks, Will. That was great. I missed a trick around the move you made to get around the regress problem. Okay, with criterion 3. The thought seemed to be that in the context of adoption, the process of adoption, which is to be rational, there has to be something kind of deliberate about the application of the statement of the rule. You have to think your way through and so infer from it. Of course, later, the need for that is dropped, you know, it becomes automatic. But I think you need to do more to motivate that distinction. It doesn't seem that the process of adoption of itself requires that if you just instinctively adopt a statement and work with it appropriately, you're acting irrationally. Okay, you're just smart.
Sorry, can you repeat the last part?
I'm calling for something a bit stronger than I heard to motivate making that distinction, right? So in the case of the context of adoption, you have to infer from the rule, okay? Applying a rule is inferring from the rule. In general, that thought's regressive. It can't be right. But in this context, it's okay. What makes it okay in this context? You said something about rationality, and I didn't get it.
Right. So this is the only place where it matters that I say at some point that I'm talking about rational adoption as opposed to merely adoption. And the thought is supposed to be what rational adoption requires is that you've gone through some rational process. And the output of that rational process was, in effect, a decision. I'm going to be guided by rule R. And then, where rule R then has the content of the rule. And the thought is supposed to be, I want that to be the beginning of a process called rational adoption, which is where I now start to infer according to rule R. And what makes my inferring according to rule R not just something that I've now just started to do, but to be part of this process of rational adoption, is that I went through this rational process that outputted I should now start being governed by rule R. And for some sufficient amount of time or number of instances, my inferring in conformity to R is sensitive to the output of that rational process. And that sensitivity is supposed to be given somewhat more precise content by what I called condition 3 on adoption. In other words, it's supposed to be made precise by the requirement that you infer from the statement of the rule.
I get the point about sensitivity. I mean, that's certainly required. But with inference in general, okay, the sensitivity can't be inferential. Right? When I make a modus ponens inference, just as it were thoughtlessly, the sense which I'm still sensitive to that being a good thing to do. If you ask me about it, I'll tell you why I did it and what my justification is. So what I do is informed by an understanding of the rule without being inferred from the rule. Okay. We need a notion of that. Instinctual rule following is not necessarily blind. It's rationally recoverable after the event. And it seems to me you've got a strong psychological point. Okay, that is, if I adopt a new rule, of course, I'm going to think about what it says in the first few moves that I make with it, and there'll be a kind of inference going on. But I don't see it's more than a psychological point, and I guess that's not really enough for your argument. Okay, if it's really psychological.
Okay, good. So what I hear you saying is, all I'm doing to motivate this extra condition during the process of adoption is this claim about sensitivity to a rational process. But you're saying, actually, inference in general, though it can't always satisfy this condition 3 on pain of regress, actually always has to satisfy some kind of sensitivity condition anyway. So if this sensitivity condition always applies, then I haven't really, then motivating via sensitivity actually doesn't do enough. And right. I guess I have some psychological story about why that sensitivity has to be somehow stronger. We should have a stronger condition on that sensitivity during the process of adoption. But if what you say about some amount of sensitivity always being required, then I haven't done enough to motivate why this specific strengthening of sensitivity should apply in these cases. Okay, great. Yeah, I take the point. I'll think about it. I don't have an answer right now. Thank you.
Okay, Romina and Saul have a follow-up.
Yeah, it's about Crispin's point. I mean, a couple of things. First, about Saul's, why Saul put it that way. I think that he was thinking on a scientific Quinian sort of model. So the idea is that you get by deliberation and reasoning to come up to a hypothesis, and then you adopt that and go by it. So it should be something similar as something that could have happened in the sciences. And in that case, it's clear that that it's something that you come to accept and then use it in your theory or whatever. And since the Quinian model is supposed to be modeled after that, right? That's what
Yeah.
what you sort of had in mind. And
Yes.
so I think that that way of putting it as you know, reconstructing what he wanted to criticize in a way about is right. Now, a couple of things about the status of the rule and the acceptance. You know, in Harry's case, because he doesn't really do it, he doesn't do that, and he doesn't have any notion of the rule or principle either, because really it won't make a difference whether you give it in the form of a principle or a rule. When he goes to apply, it will become a rule anyway for him, even if it's not formulated as a rule. But you know, we have to give it to him explicitly. But at least for me, the argument is supposed to work also for some kind of implicit acceptance, where content is supposed to implicitly guide you. And there isn't, you know, like an acceptance like you need in Harry's case, because I can't see why it would make a difference to make the content work implicitly. I mean, if anything, me telling it explicitly to Harry should make him work better with it if it were possible. But if you send it implicit, that's not gonna make it any better, in the same way that, you know, like what you were saying about a priori and empiricism doesn't really, because it goes to another issue that affects more like the statements themselves and not how they are justified. And here, in a way, it's the same. It doesn't really matter whether there's an explicit acceptance or we are thinking in terms of some kind of, you know, Chomskyan universal grammar, where this content is represented and applied, but it's not in the front of our mind. And so, I mean, I think you presuppose throughout that there was going to be something that would have to be explicitly accepted because you're interested in revision. And in that case, of course, you know, you consider something. And but I take the argument to be something a bit more general than that. You see what
So I'm not sure. I did think that the condition, the thing I called the condition 3, which I said, you know, based on a statement of the rule, I actually think that was unnecessarily strong. It just has to be I think it seemed like it needs to be something that carries the content of the rule, and it doesn't have to be explicitly a statement.
right?
But
That
unless
doesn't make a difference. That's what I'm trying to say.
right, and I don't think it makes a difference. Sorry,
yeah. As long as there is something propositional guiding, even if it's implicit, there's going to be trouble. About the formulation of 3, one comment that I had was that, you know, you formulated in a kind of a biased way, as including the word inference in it. And really what you do is you just give it and you assume that from the statement or from what you are telling him, you will have to come out the practice itself. He will have to infer according to it, or in conformity with it, whatever, according to it, let's say. But you know, but then you see that to actually be able to do that, then he has to infer from the rule itself. That's not supposed to be a condition, you know, something that is like the upshot. You see what I mean? That you say, well, you know, how is he gonna get anything out of here? Well, he'll have to infer, and because otherwise, you know, it just adds the statement, but the statement doesn't do any work whatsoever. And
okay. So, I mean, I definitely take the point about not needing an explicit statement, and I agree with that. Now, I guess what you're saying also is you need to follow the to follow the rule. To start following the rule, you have to be guided by something that carries the content of the rule. But we're not supposed to build in that guidance is inferential. That's supposed to come out.
Well,
Is that what you're
it
saying?
will come out because, I mean, he won't be able to. I don't think he could even understand the statement of the rule really without being able to do UI. But that's, a level up, because I think you can reformulate the problem in terms of meanings. But independently of that, the idea is, well, you give him that, and what you see is that there will be no way for him to do anything whatsoever with that rule that is appropriate if he can't do already instantiation, which is really what is fundamental. It's not the rule, it's the capacity to instantiate. That's what is really fundamental here.
Yeah.
And
I think it just seems to me that if you do it that way, you kind of need this extra premise, which is that you're not able to be guided by some content unless you infer from it. And in a way, I feel like I'm always trying to work with a maybe slightly narrower version of the adoption problem that feels safer because it doesn't need that additional premise.
it's really not the premise, but something that you see that results from his inability to do anything with what you've told him, and that, yeah, I mean, like, I remember Michael when he first encountered this, he talked about causing, and about causing, the rule causing hiring to infer, and so on. And the relationship will have to be inferential. But that's supposed to be, a result of we trying it out and seeing that it doesn't work, more than a premise of the argument. I'm not sure that it really makes a lot of difference to what you're trying to say, but it does get to a general comment that I have, and is that I think that you're looking at it from a very formal point of view. And I'm not sure that looking at it from there gets really to the heart of the problem. Because, look, for instance, take what you were saying about adjunction. Really, you say, well, I can give it in terms of modus ponens, but why can't you give it in terms of modus ponens? Because modus ponens is really two things. One is putting together the premises, and then is, making the inference. So in a way, adjunction is already built in. And sometimes when you think from a formal point of view, those things get lost. But the fact that the connective doesn't appear doesn't mean that you are not doing that, And that's why I'm saying that I get this feeling that there's a tendency to think, and I know that that's what you like, so, but I don't, so I don't tend to have that problem. Maybe it's biased on my end, but I mean, I think that, that story about the formal fallacy, formal system fallacy, and so on, is supposed to sort of point out that there's gonna be some kind of reasoning that is intuitive, and that is not gonna be completely captured in a system, any system, because it will always have to go in the background.
Right.
Yeah. And well,
So
that's a general comment, but we can. I know it's very hard to.
So let me address both things. With respect to the first thing that you were saying, this kind of discovery that you're supposed to have, that being guided by the rule is going to have to involve inference. I think if you hold on to that in general, you will end up being in Crispin's regress. So I think that's in a way that's another reason why I don't want to have that. I don't want to accept that thought in general. And okay, and as to the second thing that you were saying, I mean, okay, so yeah.
Not really a regress, more like a paralysis, because he won't start. Right.
Yeah, okay. Right. I mean, yeah, with respect to the second thing that you were saying, I mean, I guess let me sort of distinguish two things you could be saying. Like, one is, just, I don't know, thinking about this in a sort of vaguely formal way is no good. And yeah, I mean, like you said, I like that stuff, so I like thinking about it in that way. But I guess one thing I want to say that I was not doing is I wasn't committing the formal fallacy in the sense of like setting things up in a formal system, and then assuming that I could use the formal system, without reasoning intuitively about it. And I, there's this quote from there's this section of the transcript of the Pittsburgh lecture where you say something like, you have to realize that the point is that you can't just say, oh, I'm going to set up a formal system and follow what I get out of the formal system, because I need basic reasoning to understand the instructions for setting up the system. And I completely agree with that. Yeah. But I think that there's still a gap to show that any rule of informal reasoning would be needed for following the instructions of how to follow of a formal system. And I actually think that the structure, part of what the structure of the adoption argument, part of what the structure of the adoption argument does is it offers us a way of seeing what informal rules of reasoning we need in order to be able to follow a kind of, a formal system. And I claim it seems to show it's the indispensable ones. Because I didn't assume a formal system. I mean, I don't know, I was using—
No, I agree with that. I agree with that. I was thinking more about the argument against adoption by building it in, how do you interpret UI and so on. And I'm not sure that it makes too much of a difference about how you construct, how you formalize UI,
I see.
Because
Ramina,
yeah.
if I may.
I should shut up. Yes. I shut up. Okay.
We'll probably have some more time at the end, so we can come back.
Yes.
Part of the reason why I wanted to interrupt is because I also like formal things, and I also had an issue with the things you were saying about adjunction, but from a more formal perspective.
Okay.
So if I could get you to return to these issues about adjunction, you were saying that it's not indispensable because you can rephrase it using modus ponens and so on in this way. But I was a little confused about the dialectic here, because you end up settling on a non-classical logic. And as you're probably aware, in many non-classical logics, these things are not equivalent. So I wasn't sure what you're doing here. Was it saying that intuitively, in whatever the right logic will be, these things are going to come out to be equivalent? That's not obvious to me. Or are you saying that, like, formally, even in this minimal logic, these things are equivalent? Because that's just false. So could you explain what was going on there?
So I think you're right. That's the short answer. I had some other issues with the indispensability of conjunction introduction, And I settled on this one as being the best. But actually, I think, but yeah, you're right. I just kind of missed that once you start saying that you need to give up other aspects of classical logic, then the equivalence of that paraphrase isn't going to necessarily, well, right. I mean, one thing is, if you do paraphrase the conditional, I mean, if you just rewrite the conditional in that way, and you have modus ponens and the initial conjuncts, can you get the end thing? You will, even in the minimal logic, that is true. Whether the two sentences will be in general equivalent is a different matter. And that's, I guess, what won't hold in general. So I think when I briefly thought about it, I thought, oh, because you can still go from the conjuncts to the consequent, it doesn't matter whether they're still equivalent. But maybe that's not true. And maybe they should still have intuitively the same meaning if they're supposed to be actual paraphrases of the content of the rules.
Yeah,
So
I mean,
actually,
I thought equivalence was the notion you were after, because you start talking about, well, sort of this equivalence under paraphrases. And that's, I mean, equivalence would have to be the notion then, right?
yeah. Yeah, okay, so I take that point. Okay, so yeah, maybe I was too quick then in dispensing with conjunction introduction. Another thought I had is that since I'm saying you need the truth rules anyway, actually, yeah, let me before I even say anything about that, let me think more about it.
Yeah, okay, so I mean, just something you might want to look at. Relevance logics, they always take adjunction as basic precisely because you can't get this sort of equivalence. So in the way that you axiomize any standard relevance logic, just for this reason. Okay, that's my last point. Gilbert, on to you.
Thank you.
Yeah, thank you. My video is not working. I'm back at your slide where you're first introducing the idea that you want to understand infer as you may infer.
Yep.
It's a failed option. Anyway, that's the slide title. There you say one may not infer A or B whenever A is true. Certainly that's right. But one must accept A to be licensed to infer A or B. Don't you mean not accept, but suppose A? I mean, you're not saying that, or are you, that in pure suppositional reasoning, there is no inference?
No, I don't want to say that. I want to, yeah, so I guess I want to say that if you accept A, then you can infer A or B. If you suppose A, then you can infer A or B under supposition.
Right.
So yeah, I mean, I guess I would have to add that. Maybe I need to add that point.
Yeah, I'm just saying accept seems too strong there.
Yeah, well,
Right.
actually, reductio ad absurdum, you would always be just supposing A, right? And then you might gives us as a reason to reject it and so on. Right?
Yeah, I mean, I guess just to answer the question, I think the infer predicate is supposed to be something that can occur within a suppositional context. So, you know, if you want to enter as a suppositional context, it seems like you can then still go from the supposing that you accept to the thing you then want to infer. If you don't want to be in a suppositional context, then acceptance is fine. So I thought that you could make this, that you could put this connection between acceptance and license to infer in a way that would be independent of what you do with suppositional context, because you can always just either do this in a suppositional context or not. that is my, yeah, that's my first attempt at how to address your question.
Right, but of course, a purely suppositional context like counterfactuality is exactly the case where you don't accept this the proposition P here.
I mean, I guess my point is, if you are arguing within a suppositional context, then you suppositionally accept the thing you want to start in, you know, you start
Yeah.
your suppositional reasoning with.
Okay, thanks.
Sure.
So the queue is open. Does Saul want to say more?
Well, I think probably Romina has said enough. Yeah.
Well, I have more to say, so you can say some too.
No.
I actually,
Yeah.
talk.
No, I mean,
And hurry, because then I'll take over, if not.
okay, now looking at this very formally, well, this is a very rich paper. I'd have to think of all the things. But well, as Romina says, I was sort of arguing for the primacy of informal reasoning and not thinking of these as hypotheses or something that one reasons from. This would be strange why we even try to prove a completeness theorem. We know what all the hypotheses are, right?
Right.
Yeah. And that applies, but I don't think like intuitionistic logic is simply a proposal to drop excluded null or drop double negation elimination. One has to say what one has in mind by this interpretation of the connectives and why. And then after Bauer, who didn't propose any formal system, like Heiding did propose a formal system, but even then, its intuitionistic completeness is a problem with intuitionistic mathematics and has various different formulations. So, yes, so I don't think this model that all the revisions are just attempts to drop something. I mean, relevance logic, which Yale just referred to, wasn't just a proposal to drop something. One has to say what one thinks is valid and why, right? Yeah. Okay, well, look, I'm probably saying enough. That's just a bunch of sort of informal remarks, right?
About, like UI, think if you have a restricted logic that restricts UI, I would think that the capacity to instantiate in general is something more basic than this restricted version, in that you actually would presuppose it in making the decision to go restricted, and because from where is that decision made? Is that, that would have to be universal, unrestricted. And, but it seems to me that, you can't restrict, but, the other thing seems to be the more basic capacity, it seems to me. And that, like, you have to say what holds. I mean, I don't see this argument, and this is a classic argument. I mean, people reply this to Saul all the time. Well, really, you're not just, you're not adopting, in most cases, you are dropping. But I don't think that that's the right way of looking at it for several reasons. But one is this one. It seems to me that the fact that you are dropping doesn't mean that you don't have to say what holds and why.
Yeah. So actually, I mean, you know, in that part of the talk, I was trying to defend the adoption argument from from the charge that it's just about dropping. And I guess I only, in the actual talk, I skipped most of what I had in the slides, but I actually do think that, yeah, even if you're just dropping, it's not like dropping is just, I'm gonna now just stop using this rule. Like I've just, you know, there has to be some kind of reason that you're dropping. And so the way I put it in the slides, which maybe you won't like, but I've started to think about this and I find it kind of interesting, is that dropping isn't just no longer using a rule, but that it's something like adding a prohibition, like adding a prohibitive rule. So when you decide to drop a certain rule, what you're really doing is taking on the rule that says, oh, you can't infer according to this. And that to me actually raises a very interesting question of, you know, we don't usually talk about prohibitive inference rules, but it seems like we should be able to have something like that as well. Yeah.
That's actually, you know, now thinking from what you're saying, that's actually something that sounds plausible if you read Putnam's paper. Don't do that. That's bad.
Yeah. Wow.
I think Kripke has a question though. Yeah.
Yes, Crispin.
You're muted, Crispin.
Yeah, my screen expanded. I didn't have the mute control anymore in view. No, it's just a kind of lateral thought, maybe relevant. Tell me if it is. How do you restrict UI? If the restriction takes the form of introduce some condition in the antecedent, the application of that is still unrestricted. Whenever the unrestricted condition is met, then it seems like there's no scope for restriction in a certain sense. There has to be unrestricted meta thought, as it were, in applying the restricted rule.
Yeah. I mean, we briefly talked about this before, Crispin. Yeah, I'd like to think more about that. I mean, what I want to say is, you can at least understand what it would be for somebody else to have a restricted version of your UI. Okay. And so, you know, we could say something like, suppose so-and-so has this restricted form of UI. Now I'm saying that, they're not saying that. And then I can say something like, if they try to adopt the full UI, you know, they'll have a hard time. And so therefore that version of UI for them is unadoptable, or, you know, they won't be able to adopt this class of rules. So therefore UI is indispensable because that person is like cognitively in a bad situation.
Right.
So I think for the kinds of things I'm saying, that's all I need to say. Now, for the tougher question of, can I say, I'm going to restrict my own UI? I think that's harder. And if you think of it in light of what I was just saying, that the decision to drop a rule is taking on a kind of prohibition. And then you think that you need to be sensitive to that decision in the way that I was laying out in that criterion 3, right? You need to be sensitive to your decision to prohibit yourself from doing something. Then the prohibitive content, in order to say, well, don't do those versions of UI. Well, yeah, you would need unrestricted UI for that. So I think if I'm right about the whole prohibitive thing, then there's actually a good case to be made that you can't restrict your own UI, but you can still talk about other people's restricted UIs.
Good. Okay. Good.
Okay.
Can I say something else?
Yes, we do have to end at 3 strictly today, but you're welcome to have the last whatever.
Okay, it's about the paraphrases. You take that to be sort of a valid objection, right?
Yeah, I mean, I don't feel too strongly about this. I partly want to say it's a valid objection. I don't know. I'm also sensitive to the thought that, like, I don't know, a paraphrase is just not as natural a way of putting the actual content of a rule. But anyway, I don't know. Say what you want to say about it.
I'm looking at them. No, actually, I mean, I'm interested in this. One of the referees made a point about this for the paper, and I think he's wrong.
For her paper.
Yes.
Right.
And well, yeah, and some of the others.
Yeah.
Well, he thinks that you're, unobjectionable. So he doesn't say anything to you, so you're lucky. But I mean, suppose, I mean, the cases are like, suppose, because I don't know how you're thinking about these paraphrases, but the way I was thinking about them is that instead of giving Harry UI, you give him something equivalent and see what happens, but you have to assume that maybe he reasons in accordance to the existential, but he's never done that one in particular that is the equivalent to the UI with negation, and that he hasn't seen the statement of the rule either, and then just to keep like the setup of the problem and see if that will work while you are giving him this alternative. And actually, trying to think about what we would tell him, I think something very similar to what we were just saying about UI happens, because, it's hard to even think how if there doesn't exist something for which a predicate F does not hold, then F holds for an arbitrary case. So you don't say a particular instance or something like that. And, but really, and then, wouldn't that generate a sort of regress? Because when he goes to apply it, how would it go about, And I don't see how the generality problem wouldn't recur at the level of the rule that we are giving in terms of existential. We'll have to say that that's a universal rule, and that they applies to everything, or we would have to try to explain it again in terms of the existential in negations. And I don't see that you can really get the effect that way of generality. And so I think that the problem with the paraphrases is like deeper in a way, and that the fact that you can paraphrase doesn't mean that, and the same for most opponents, because when he tries to apply whatever you tell him, he will have to make it a rule-like, even if you do it with conjunction and try to avoid any conditional whatsoever. So you don't see a conditional in the formulation that you give him, but that doesn't mean that when he goes to the world and tries to find instances, he won't have to do most opponents,
I mean, I guess the question is, how realistic do you want the case to be, right? Because I think the idea is, if the paraphrase is really equivalent, then he should be able to go around wherever you're saying he still needs to think conditionally about this thing. You can just think, in terms of the disjunction of a negation and negation of the antecedent and of the consequent. Like he can just think of it in those terms as well. Now, realistically, that's not how we think, right? We don't think, we think in terms of all, and it's very awkward to think in terms of like negations of existentials every time we want to think about universal claims. But if the equivalence is genuine, then you should be able, wherever you think actually one step back, he has to think in terms of all. He could think in terms of negations of existentials there too. At least, in theory.
And that's probably what the referee is going to answer me, Because you never persuade anyone here. Okay, I'll tell you how it goes.
By the way, Romina, I meant to ask you this before. I would love to get a version of the paper that you did recently on this.
Okay, sure.
If you can send it to me.
Yes, sure. And I'm going to take a look at the slides and see if I can send you some comments.
Yeah.
Okay.
It's a very rich paper, so it's hard really to. Yeah.
I didn't know they had written on this.
Yeah.
I mean, I did it just for Paul and Crispin's class.
I know, yeah, but yeah. Okay,
All
yeah.
right, shall we thank the
Let's
speaker
go.
one more time?
Okay, thank the speaker.
Thank you so much.
Thank
It
you
was
for a very
great.
rich paper.